And of course, a benefit of that is like we're not giving up on code. Like we still want to treat policy as code. We want to be able to test it. We want to be able to review it. We want to work with all of these things like lint it or whatnot. We want to work with all these good tools and processes that we kind of established for any development. We want to kind of piggyback on that for policy just as we do for anything else. So if you want to change something in a policy, the way you do that is you submit a pull request. It's not like you need to call a manager or you need to submit a form or something. That is how it used to be, right? But we want to, as developers, we want to work with these kind of things like we work with any other type of code.
Hello, everyone. Welcome back to this week's episode of simplyblock's Cloud Commute podcast. Today, I have a guest with me that I actually never met in person, as far as I know. I don't think we have.
No,
But
I'm not.
maybe just say a few words about you. Where you're from, who you are, and what you're working with.
Sure. I'm Anders. I live here and work in Stockholm, Sweden. And I work as a developer advocate or a DevRel lead even for Styra, the company behind the Open Policy Agent or OPA project. So I've been here for, I think it's 3.5 years or so. Before that, I was at another company and that's how I got kind of involved in the OPA project. We had a need for a solution to do access control or authorization across like a very diverse and complex environment. And I think we had development teams in 12 different countries. We had like 7 different programming languages in our cluster, and it was just a big mess. So our challenge there was like, how do we do authorization in that kind of environment and without having to go out to all of these teams and try and coordinate development work with each change we need to do. So that's basically how I got involved in the OPA project. OPA emerged as a good solution to our problem at that time, and yeah, all these years later, and I'm still here and I'm having a lot of fun.
All right, cool. So you mentioned Styra. I always thought it was Styra, to be honest, but okay, fair enough.
Yeah, no, like the
Learn
Swedish
something.
pronunciation would be Styra, which is so you're definitely right. It is a Swedish word which means
Huh.
to steer or to navigate. So
Oh, okay. Yeah,
so
so the
you're
technical would
absolutely
be
right.
Cheyenne.
I'm
Yeah.
just I'm just using the Americanized, the bastardized pronunciation.
That's that's fair. Probably because I'm German, that would be my initial like thought. And it kind of makes sense. So in German it would probably be Steuern or something. All right. So tell us a little bit about Styra. You already mentioned the OPUP project. I guess we're coming back to that in a second, but maybe a little bit about the company itself.
Yeah, sure. So yeah, so Styra was founded by the creators of OPA, and the idea, or I think like so that is like the main thing. Like everything at Styra revolves around OPA, and I think it always has, and I'm pretty sure it always will to some extent. Uh, so Styra, what Styra does is we created and we maintain the OPA project. We created and maintain a lot of the things you'll find in the ecosystem around OPA and Styra. And also, of course, we're a commercial company. So there's 2 products that are all both based around OPA. One is Styra DAS, which is a commercial control plane, which
Mhm.
allows you to manage OPA at scale. So like from the whole kind of policy life cycle. And then there's an enterprise distribution of OPA as well, which has basically a whole different runtime, which allows it to consume much less memory, evaluate faster, connect to various data sources, and so on. So yeah, so basically both the kind of the distributed component and the centralized component.
Right. Okay. You mentioned OPA a few times, and I think you already mentioned what it really means, but maybe we need to dig into that a little bit deeper. So I think OPA is the Open Policy Agent. And if I'm not mistaken, it's a framework to actually build policy, as we call it, policy as code.
That's right. That's right. So yeah, the idea behind OPA is basically that you kind of you define your policies as code, but not just code as like any other code running or uh, which is kind of coupled to your applications, but rather that you try and decouple that part of your code and move it outside of your application, so you can work with that in isolation. And some common use cases could be things like authorization. And I mentioned before this need where you have like a complex environment, you have a whole bunch of services, and you need to control authorization. How do we do authorization here? How do we make changes to this at runtime? How do we know what authorization decisions got logged and or what people did in our systems? So how do we do auditing of this? So that is one type of policy, and it's a very common one. But it doesn't stop there. Basically, anywhere you can define rules, you can define policy. So other common use cases are policy for infrastructure, where you want to say like I don't want to allow pods to run in my Kubernetes cluster unless they have a well-defined security context, or if they don't allow like mounts of certain types and so on. So you basically define the rules for your infrastructure, and this could be things like Terraform plans, Kubernetes resource manifests, or simply just JSON and YAML files on disk. So there are many ways to, and many places where you might want to enforce policy. And the whole idea behind OPA is that you have one way of doing it, and it's a unified way of doing it. So there are many policy engines out there, and most of them, they do this for one particular use case. So there might be a policy engine that does authorization, and many other that does infrastructure and so on. But that all means that you're still going to end up with this problem where policy is scattered all over the place. It looks different, it logs different, and so on. While with OPA, you have one unified way of doing this, and to work with policy across your whole stack and organization. So that is kind of the idea behind OPA.
So that means if I'm thinking about something like simplyblock being a cloud native block storage, I could prevent services from mounting our block devices through the policies, right? So something like that. Okay, cool. You mentioned authorization. I guess that is probably like the most common thing when people think about policy management in general. What I kind of find interesting is in the past when you did those things, there was also often the actual policies or the rules for or permission configuration or something. I was already like a configuration file, but with OPA you kind of made this like the first class spot. Like it should not be in your code. Here's the framework that you can just use, drop into or drop before your application, I think, right? It's not even in the application itself.
No, I guess it depends, but most commonly you'll have like a separate policy repo where that goes. And and of course, a benefit of that is like we're not giving up on code. Like we still want to treat policy as code. We want to be able to test it. We want to be able to review it. We want to work with all of these things like lint it or whatnot. We want to work with all these good tools and processes that we kind of established for any development. We want to kind of piggyback on that for policy, just as we do for anything else. So if you want to change something in a policy, the way you do that is you submit a pull request. It's not like you need to call a manager or you need to submit a form or something. That is how it used to be, right? But we want to, as developers, we want to work with these kind of things like we work with any other type of code.
Right. So how does it look like from a developer's point of view? If I mean, you can use it to, I think, automatically create credentials for something like Postgres, or is that the DAS tool? Do you need one of the enterprise tools for that?
No, yeah, creating credentials, I guess like you could definitely use OPA for that, but I think in most cases what you use OPA for is basically to make decisions that are either most commonly they're yes or no. So like, should we allow these credentials would be probably a better use case for OPA. Like, no, we should not allow them because they're not sufficiently secure or what have you. But yeah, you can use OPA and Rego, the policy language, for a whole lot of things, and a whole lot of things that we might not have designed it for initially. So as an example, like there's this linter for Rego, which is called Regal, that I have been working for the past year or so. And that linter itself is written mostly in Rego. So we kind of use Rego to define the rules of what you can do in Rego, which
I smell Inception.
yeah, there's a lot of
All
that.
right. I mean, you know that your language is good when you can build your own stuff in your own language, right?
Exactly.
So coming back to the original question, like, what does it look like from a developer's point of view if I want to access, for example, a Postgres database?
Right. So the way OPA works, it basically acts as a layer in between. So you probably have a service between your database and your user or another service. So rather than having that our user or service go right to the database, they'd query that service for access. And in that service, you'd have an integration with OPA, either with OPA running as another service or running embedded inside of that service.
Right.
And that OPA would determine whether access should be allowed or not based on policy and data that it has been provided.
Right. Okay. Got it. I actually thought that, or maybe I'm wrong because I'm thinking one of the enterprise features or enterprise products. I thought it was its own service that handles all of that automatically, but maybe I misunderstood, to be honest. So there are, as you said, there's OPA Enterprise, and there is DASV, Declarative Authorization Service.
Yeah, that's right. You got that right.
Remembered right. So maybe tell us a little bit about those. Maybe I'm mixing things up here.
Sure. So I talked a bit about OPA, and OPA acts as the distributed component or the decision point. So that's where the decisions are made. So OPA is gonna tell the user or another service, should we allow this or not? And once you start to have tens or 20 or hundreds or thousands of these OPAs running in your cluster, and if you have like a distributed environment and you want to do like zero trust microservice authorization or whatnot, you're going to have like hundreds or thousands of OPAs. So the problem that Styra DAS solves is essentially like, how do we manage this at scale? How do I know what version of which policy is deployed in all these environments? How do I manage policy changes between like dev, test, prod, and so on? But it kind of handles the whole policy lifecycle. We talked about testing before. We talked about things like auditing. How are these things logged? How can I search these logs? Can I use these logs to replay a decision and see, like, if I did change this, would it have an impact on the outcome, and so on. So it's basically the centralized component. If OPA is the distributed component, Styra DAS provides a centralized component, which allows things like a security team or even a policy team to kind of gain this level of control that would previously be missing when you just let any developer team handle this on their own.
So it's a little bit like fleet management for your policies.
Yes, that is
right. Okay, that makes sense. And the DAS specifically, that is the management control or the management tool, or
yeah, that it is.
Okay.
That it is. And then Enterprise OPA is a drop-in replacement for OPA, adding a whole bunch of features on top of it, like reduced memory usage, direct integrations with data sources, things like Kafka streaming data from Kafka, and so on and so forth. So we provide commercial solutions both for the centralized part and the distributed part.
Right. Okay. I think now I remember where my confusion comes from. I think I saw OPA Enterprise and saw the services, which are basically source connectors. Okay, now it makes sense. Yeah, okay, got it, got it. So from I think you already mentioned Kubernetes before, but how does that work in a Kubernetes environment? I think you can, as you said, deploy it as its own service or run it embedded in microservices. How would that apply together somehow? I mean, we're a cloud podcast.
Yeah, of course, of course. Yeah, so in the context of Kubernetes, there's basically two use cases. Like the first one we kind of covered, it's
Hmm.
authorization in the level like inside of the workloads. Our applications need to know that the user trying to do something is authorized to do so. In that context, you'd normally have OPA running as a sidecar,
Hmm.
uh, or in a gateway, or as part of like an Envoy Istio proxy or something like that. So it basically provides a layer on top or before any request is hitting an actual application. So
Right. In the sense of user
yeah,
authorized. Right.
yeah,
Okay.
exactly. So and the next content or the next use case for OPA in Kubernetes is commonly like admission control, where Kubernetes itself or the Kubernetes API is protected by OPA.
Oh.
So whenever you try and make a modification to Kubernetes or the database etcd, the Kubernetes API reaches out to OPA to ask like, should this be allowed or not? So
Oh.
if you try and deploy a pod or a deployment or a, I don't know, what have you, what kind of resources, uh, OPA will be provided at resource. Again, it's just JSON or YAML. So anything that's JSON or YAML is basically what OPA has to work with. It doesn't even know, like OPA doesn't know what a Kubernetes resource is. It just
Right.
sees like, here's a YAML document or here's a JSON document. Is this or that property that I expect, is it in this JSON
Mhm.
blob, and does it have the values that I need?
Right.
If it doesn't, it's not approved. So we're gonna deny that. So basically, just tells the Kubernetes API, no, this should not be allowed, and the Kubernetes API will enforce that. So the user will see this was denied because this or that reason.
So that means I can also use it in between any Kubernetes services, everything or anything deployed into Kubernetes, I guess, right? Not just the Kubernetes API
Yeah,
itself.
and anything you try and deploy, like for modifications, it's gonna have to pass through the Kubernetes API.
That's a really interesting thing. So I guess going back to the simplyblock use case, that would probably be where our authorization layer or approval layer would sit. Basically either approving or denying the CSI deployment.
Yeah.
Okay, that makes sense. So um because we're already running out of time, um do you think that, or well, I think the answer is yes, but maybe you can elaborate a little bit on that. Do you think that authorization policies or policies in general became more important with the move to cloud? Probably more people having access to services because they have to, something like that.
Yeah, I'd say like they were probably just as important back in the days. What really changed with like the invent of cloud and this kind of automation is the level of scale that any
Right.
individual engineer can work with. Like you'd in the past you'd have an infra engineer would perhaps manage like 20 machines or something like that, while today they could manage thousands of machines or virtual machines in cloud instances or whatnot.
Mm.
And once you reach that level of scale, there's basically no way that you can do policy like manually. That you have a PDF document somewhere where it says like you cannot deploy things if unless these conditions are met, and then have engineers sit and try and make an inventory of what do we have here, and are we all compliant? That doesn't work. So that is basically the difference today from from how policy was handled in the past. We need to automate every kind of policy check as well, just as we automated infrastructure and so with cloud.
Yeah, that makes sense. I think the scale is a good point about that. It was not something I thought about. I thought in the sense, or my thought was more in the sense of like you have probably much bigger teams than you had in the past, which also makes it much more complicated to manage policies or make sure that just like the right people have access. And
Oh
then
yeah,
you
for sure.
sometimes have to have this like access because somebody else is on vacation, and it will never be removed again. We all know how it worked in the past.
Yeah. No, and another difference I think like today compared to 20 years ago is like, at least when I started working in tech, it was like if you got to any larger company, they're like, hey, we're doing Java here, or we're doing like .NET. But if you go to those companies today, they're like, there's going to be Python, there's going to be Erlang, there's going to be some closures running somewhere, there's going to be like so many different things. This idea of team autonomy and like teams deciding for themselves what the best solution for any given problem is. And that is, I love that. It's like it makes it so much more interesting to work in tech, but it also provides like a huge challenge for anything that is security related, because and anywhere where you need to kind of centralize or have some form of control, it's really hard. How do you audit something if it's like in 8 different programming languages? Like I can barely understand 2 of them. Like how would I do that?
How to make sure that all the policies are implemented. If policy change happens, yeah, you're right. You have to implement it in multiple languages. The descriptor language for the rules isn't the same. Yeah, that's a good point. That's a very good point, actually. And just because time, I think I would have like a million more questions, but there's one thing that I always have to ask. What do you think is like the next big thing in terms of cloud? In your case, authorization policies, but also in the broader scheme of everything.
Yeah, sure. So I'd say like first of all, I think both identity and access control, they are kind of slow moving, and for good reasons. There's not like there's going to be a revolutionary thing or disruptive event that turns everything around. I think it that's basically where we have to be. We kind of rely on things to not change or to update too frequently or too dramatically. Uh, so yeah, what would the next big thing is? I still think like this area where we decouple policy and we work with it consistently across like large organizations and so on. It's still the next revolutionary thing. It's like there's definitely a lot of adopters already, but we're just at the start of this. And again, that's probably like organizations don't just swap out their like how they do authorization or identity. That could be like a decade or so. So I still think this policy as code, while it's starting to be like an established concept, that it is still the next big thing, and that's why it's also so exciting to work with in this space.
All right, fair enough. At least you didn't say automatic AI
Oh,
generated.
AI, no, God, no.
That would have been really the next big thing. Now we're talking. No, seriously. Thank you very much. That was very informative. I love that. Yeah, thank you for being here.
Thanks for having me.
And for the audience, next week, same time, same podcast channel, however you want to call that. Hope to hear you again, or you hear me again. And thank you very much.